In this video, we will look at the concept of a function. Let's start by looking at functions in general. A function is a block of code that performs some specific task. Sometimes functions are called routines or procedures. The function has a name. The input values to a function are called its arguments. A function can produce some output data. We refer to this as the function's return value. In order to execute a function, we need to call it from some other code. When calling a function, we specify its name and the input arguments. The diagrams show that the arguments are processed by the function. The return value is assigned to a variable called result. Here is an example of a function with a return value. The function generates random numbers. In the example, we call the function by specifying two arguments. The function will generate a random number between 0 and 10. The return value of the function is assigned to the variable called result. Here is an example of a function with no return value. The function adds data items to a list. In the example, we call the function by specifying the list and the item to add. We can assume that the function will add the number 15 to the end of the list. There is no return value. When using function in libraries, they are generally grouped into modules. These modules also have their own names. The way that you specify the module and function name differs by programming language. One common approach is to specify the module name, followed by a dot, followed by the function name. In the example, the list module contains two functions called add and remove. Functions can have internal logic that allows them to change their behavior depending on the input arguments. When calling such a function, you can vary the input arguments to achieve different outcomes. This is called overloading the function. There are three ways that functions can be overloaded: arity, data types, and data structures. The first type of function overloading is with arity. Arity refers to the number of arguments that a function expects to receive. In the example, we look at the function called range. It generates a range of numbers. It can accept either 2 or 3 input arguments. If you give the function 2 arguments, then it will generate a range of numbers with a step size of 1. If you give the function input arguments, then the third argument controls the step size. Internally, we can imagine how the range function works. A conditional statement can be used. The condition will check the number of arguments. If the number of arguments is only 2, then the function sets the step size to the default value of 1. The second type of function overloading is with data types. A function can accept arguments with different data types. In this example, we look at a function called len. The function can be used to get the number of items in a list, or to get the number of characters in a string. Let's imagine how the range function might be implemented internally. A conditional statement can be used. The condition will check the type of the input argument. If the argument is a list, then the function will count the number of items in the list. If the argument is a string, then it will calculate the number of characters in the string. Here is another example. In this example, we look at the make.Copy function. It makes copies of entities. The first argument is the entities to copy, and the second is the vector to move them by. The first argument is overloaded. You can either pass in a single entity, or a list of entities. The data types of the first argument can therefore be different. The data type can be a single entity ID or a list of entity IDs. If it is a list, then the function would have to iterate over the entities in the list. Let's look at the third type of overloading. It is overloading with data structures. In this example, we look at the make.Position function. For the data structure, the function will look at how the lists of coordinates are structured. If you pass the function a list of 3 numbers, then it will generate a single position and return that position. If you pass the function a nested list of lists, then it will loop over the outer list. For each sub-list that it finds, it will generate a position. After creating all the positions, the function will return the list of new position it created. Let's again imagine how this might be implemented internally. In this case, the control structure will be a little more complex. At the top level, there can be a conditional statement that checks the data structure. The condition will check the data structure of the input argument. If the data structure is a list of 3 numbers, then the function will generate a single position and return that position. If the data structure is a nested list of lists, then the control flow will move to a looping statement. The looping statement will iterate over the nested list and will generate one position for each sub-list that it finds. When it has finished looping, it will return all the new positions.